Next, we welcome the Center for Food Safety and Applied Nutrition from CIFSAM's Division of Information Technology Management, DITM. We will hear from Bhavani Das, Pedram Farid, Lauren Gortenberg, and Robin Barringer with their presentation, Transforming How the FDA Foods Programs Receives and Uses Data.
Thank you, Mary. This is Bhavani Das. I'm from Center for Food Safety and Applied Nutrition. With me to my left, Lauren Gortenberg. She's our center lead for everything related to data. And with me also Pedram Farid, who is our lead for application modernization as well as new technology integration. Shortly, joining with us will be Robin Barringer. She's our AD-CIO. What a great presentation by Robin. It was an amazing presentation. I loved it. I mean, it tells us the story every day we do. The engineering team, the data team, and a skilled driver. That makes it happen. Even if he was, it sounded like he was driving something that rhymes with my name, but I think I have a better story to tell you guys here. So I'm going to talk about a dog food manufacturer in, it was located in the United Kingdom, and the story is about somewhere in 1991. They wanted to go through, get certified with ISO 9001.
Sorry, our clicker isn't working.
Okay, well, it'll work eventually.
Yeah. There we go.
Yeah, it's like everything you do, there will always something, technology, right? So, so this dog food manufacturer, they wanted to get certified ISO 9001, which is a certification for a manufacturing organization. And this certification, or this is governed by international standard organization based out of Geneva, Switzerland. And in case you're wondering, this is something similar to CMMI that we have for our service industries. And in those days, in 1991, ISO was a big deal. This was like everybody, all the manufacturing organizations, they wanted to get certified with ISO. They applied for it, they went through the review, they modified their processes, they improved their process, the production facilities, the packaging, and they got certified. And once they got certified, they made sure it reflected in their marketing material as well as their packaging. As expected, their sales started going up because, who doesn't want, everybody loves their dog. I would love to buy some quality product, right? So, that's not the end of the story. After a few months, they really noticed that sales started going down. And this was very, very, concerning story for them. So it went down to a point, it was really, really a concern. So that's when, just like when we have a problem, we hire you guys, they went and hired outside organization for do some analysis for them to tell them what's wrong with them. So this company came in, ISO also was embedded with them. They reviewed their processes, their production, their packaging, everything was great. Then they looked for, okay, maybe there is a new competitor out there. That was not the case. It was even more puzzling. So that's when they decided to do a customer survey. When they did that, they realized the people who bought this, they really liked the fact that this is a great quality, nutritious product for their dog. But the end user, in this case, the dog, did not like the food and would not, it would not finish, so stop buying it. So that's what happened. And this teaches us is an amazing lesson. Many times, know your customer. Know who is the customer, what is your business driver, what is it that they're trying to achieve, what problem you are trying to solve, and what is the end product or end goal that you are trying to do it. So we in IT, we always get excited with new technologies, the buzzwords, and this is a similar story I've been hearing from the beginning, right? but it's ultimate, and our data journey within Center for Food is somewhat similar. Let me turn it over to Lauren, and she's going to walk you through, talk about what we do and how we have adapted for customer success. Thank you.
Thanks,
Lauren.
Great. Thank you for switching the slides, too. So I'm Lauren Gordenberg. I love that story because I think people really underestimate how picky their dogs could be about eating. But just to reinforce this idea about looking to our desired business outcomes to drive our IT and data modernization journeys, what we wanted to talk with you a little bit about today is the F and FDA. So we'll give you a high-level overview of the Foods program, where we are, so what are the traditional ways that we've been collecting and using data for the Foods program. Then we'll talk a little bit about where we are on our Foods program data journey, how have we been transforming to date, and where do we see ourselves going. Lastly, we'll talk a little bit about some of the emerging strategic business drivers that are helping to inform our data modernization journey moving forward. And lastly, we'll try and leave some time for Q&A, but we're a pretty chatty group. Can you switch to the next slide? Thank you. Okay, so the F and FDA. The FDA is responsible for overseeing roughly 78% of the U.S. food supply. So that includes all imported and exported foods, with the exception of meat, poultry, fish, and some shell eggs. Those products are actually regulated by other federal agencies, namely USDA and NOAA. So when we talk about oversight at the FDA and oversight of the food supply, what we mean is the continuous monitoring, what's referred to as surveillance of the food supply. And what we're surveilling is threats. We're looking for threats in terms of foodborne illnesses, foodborne outbreaks, but also the potential for intentional adulteration of the U.S. food supply. So the FDA Foods program has actually been on a fairly intensive transformation journey from a business point of view for roughly the past decade. In 2011, the Obama administration signed the Food Safety Modernization Act into law, known as FSMA, and that was really the first major overhaul in food safety legislation since the early 1900s. So since the time of the jungle and Upton Sinclair, for those of you who are food history enthusiasts. And the result of the FSMA legislation for us was obviously a very significant shift in how the FDA had to conduct food safety inspections, how the FDA was evaluating food safety risks, the risks in terms of the products, as well as the establishments that we're regulating and how they're manufacturing their products. And then also, a fairly significant challenge was also figuring out how we were going to collaborate with state and local governments and even foreign governments to ensure the overall safety of the U.S. food supply moving forward. So that's very broad strokes what the FDA Foods program focuses on, sort of the what. In terms of the how, one of the things that I think was emphasized in some of the panel presentations yesterday was that we've done a lot of siloed IT development historically at the FDA, and that's certainly been true for the Foods program as well. But one of the tools that the FDA Enterprise has given the centers is something called the Business Capability Model, and that allows us to map all of our IT applications to a standard set of business capabilities, and it helps us to talk about our IT in terms of core business capabilities. And so in terms of the food programs, we do many, many things, but the core capabilities we wanted to go over with you today fall under these buckets called regulatory review capabilities and scientific operations capabilities. Regulatory review capabilities are really the bread and butter of food safety. So here we're talking about the IT systems and business processes that allow the FDA to capture food manufacturing establishment registration data. We're talking about the systems that allow us to evaluate the safety and compliance of various food products and the establishments that produce them. We're also talking about the processes that allow the FDA to enforce some of these regulations. And then lastly, we're also talking about the IT systems and business processes that allow us to respond in the case of emergencies. So when there are foodborne outbreaks, These are our outbreak response systems, also our adverse event reporting systems, and then lastly, our product review and approval systems that allow us to accept data from industry when there are new ingredients or new products that have to be approved before they go to market. And I'm going to hand over the discussion of the scientific operations capabilities to Babani.
Thank you. So scientific operations domain, it represents the ability to conduct high-quality, collaborative scientific activities that advances regulatory science to address important public health-related activities, right? So any public health-related issues that deals with food, and it includes both human and animal food. In there, we have two branches within that, regulatory science as well as laboratory management analysis. Let me give a couple of examples to explain what happens within regulatory science and what happens in this thing. So one of the systems we have under regulatory science is based on a whole genome sequencing. This is a brainchild of Dr. Musser. And in there, I know earlier today we heard a lot about master data management. So in other way, what we are doing is any foodborne pathogen, any pathogens that causes foodborne illnesses, we kind of have a master data of all these things in collaboration with NIH. It is housed at NCBI. And we have this genome tracker workflow system. So anyone with a sequencing file can go through the workflow to identify if there is a match so that you can know more metadata, additional information. If it's not there, then you can add in additional, any information such as where this pathogen was found, what was the source, what was contaminated, a few other information. And this is growing. It's almost 500,000 different signatures, and it really helps us in this at the time of outbreaks. Previously, it used to take weeks, sometimes months. Frank talked earlier today how it used to take longer. Now, with this method, using sequencing, we are able to trace or find the origin of or source of issues very quickly. The other example I would like to give is, so all these things happening until now, we have been talking a lot about food safety, right? Issues with food. I think we are advancing, and there are more and more thinking around nutrition and healthy food. So there is a proposed law recently that once that passed, where you can easily go in, pick up a product, and know whether it's healthy for you or not. How nice that would be. So those are some of the things that are being worked within CIFSAN. It's a highly science-based center. Most of our activities happen based on science, right? So the other thing that we have there is lab management. So a lot of, anytime there is an inspection or a sample is collected, all those methods are created within CIFSAN, and it is documented. So knowledge is transferred to ORA for further, using that for field activities. So these are two major, I thought by giving some examples, I would be able to explain you what happens within CIFSAN in the field of scientific operations. Lauren.
Thank you. And if we leave you with nothing else about your understanding of the F and FDA, it's that it's a very complex program. A lot of very important work is being done every day to keep the U.S. food supply safe, to keep the U.S. public healthy, and we're very lucky to be supporting such an important mission. Can I try the next slide? Whoops. There we go. Am I doing it or you? Here we go. Got it. Thank you. Okay. So in terms of our traditional approaches to data receipt and use, traditionally we've been using a program-based approach to business process automation where we've been developing one-off solutions to support program-specific needs, individual programs. And within our center, what that looks like is roughly 50 IT applications, disparate IT applications that support similar business processes, capture similar data, but are all different. If you look at the slide and you see under data sources, these are all the business capabilities Babani and I were just describing to you, and you can kind of think of these as buckets of systems. So for registration and listing, we might have 6 or 7 different IT systems that are capturing registration and listing data for different types of foods, products, or commodities. For post-market safety and surveillance, we might have 15 to 20 different systems that are supporting the surveillance of different commodity areas, and so on and so forth. So what's happening, the result of that has been that we have this somewhat rigid way of collecting data for one program and then reporting on the data for that program. So it's sort of data in for the program and then report out for the program. And I want to talk a little bit about the challenges to this approach. But before I do, I also wanted to give Babani the floor again, because he's forever reminding me about the value of program-level reporting. So go ahead.
I know she needs a break. That's why she's handing it over to me. So, I'm sure silos are a challenge, but we are definitely trying to organize them by capability. We will try to reduce redundancies, but I don't think we'll ever be able to 100% eliminate any silos. So that is something that's a reality. I would like us as a data, engineers to understand that. So in some cases, we'll have within our capability to be able to organize, eliminate those silos, but in many cases we won't. I mean, there are things that's just not in our control. We have to deal with it. And there are places like we are getting data from CBP. I mean, we may not be able to get the data the way we want it. There will be different data sets. So our systems, our platform has to be aligned, has to be capable enough to bring in the data, organize it, cleanse it, put it together so it works for us. I get it, it is going to take some time, but the reality is we will never be able to eliminate all the silos.
He's right, of course, but what's happening with data silos right now for the foods program is that we're actually reinforcing knowledge silos. So people within different program areas aren't getting exposure to different data sets, and that's due to this lack of transparency and lack of clarity around how to get access to different data sets. So people in the foods program and in our center more broadly don't necessarily have an awareness of what other programmatic level data is available to them that they might be able to make use of for their analytics, for their reporting, for their research. Taking that issue and kind of expanding it forward, let's say that you are a data scientist or a data analyst in the foods program and you find another data set that you want to use and you want to work with and you're able to get access to it. Now you've got it. Now you start dealing with what we're referring to as data interoperability issues. We really have not been meaningfully and systematically governing our data to create standards for foods data. We have not been working systematically to harmonize product data, so foods product data is a great example of that issue. And so our analysts and scientists are spending a very significant amount of time doing transformation and cleaning for these data sets in the interest of integrating them and making them more interoperable. And that has been something that has been very challenging for the foods program. But overarchingly, the biggest issue we're seeing is that we're not necessarily able to ask and answer broad strategic questions about the foods that we regulate, the products we regulate, and then the establishments that we regulate, or the hazards that we're trying to mitigate. And that's something we're trying to change moving forward. And so with that, I wanted to hand it over to Pedram here, who's going to talk a little bit about our data journey, how we've gotten here, and where we're going.
So what have we been doing? It sounds like we're talking about a lot of problems, and why haven't we been solving any of these problems in the past? And how did it take us so long to get here? Well, when we started when Cipsan leadership started the digital transformation back in 2015, we didn't have a data group. Data wasn't even on our minds, honestly. We were application heavy, and our main goals were to eliminate duplications of effort and lower cost. To our leadership, IT was a cost, and a good IT management was to lower the cost and not be seen, right? So that's where we were at. And as we started to do the digital transformation, I think a lot of our eyes got opened and a lot of leadership's eyes got opened as we started to dig into the business capabilities, and we started to see some catastrophic data issues. And we also realized that most of our application issues were really data issues. So the first problem we found was that a lot of our reporting across all the applications were being done off of the transactional databases. So I have all these notes to explain what that means and why it is that that's a issue. But every time I went over the presentation with, family members or anything to prepare for this, I noticed their eyes just kind of glazed over. So I'm not going to do that. Instead, what I'll do is I'll just give you a very, very short answer, and that's that if you take normalized data that's, if you have a normalized database that's suited for the intake, then your reporting is going to be slow. If you want fast reporting and you denormalize the database, then transactional data coming in can be compromised and you could have data quality issues. So you can't have the transactional database and the reporting database be the same database. Another problem we found, and that's actually a much bigger problem, and one that Lauren's been alluding to this time, is that all of our programs were in programmatic islands, right? So they knew what data they had. They didn't know what other data was being gathered across the center or across the agency. And so oftentimes the only tools they had to work with was the data that they had in their hands. If by chance they did manage to get a data set from another group or something did come by their desk, they had no idea what the actual source of that data was, or if they did know the source of the data, they didn't know how many hands it had gone through and how it had been changed on the way over there. So those were some pretty big, huge problems. We had a huge chain of custody issue. And I think, we all wanted to solve those problems right away. But one of the things that we realized is, we just found out that we have twice as many problems than what we were trying to solve to begin with, and our resourcing isn't changing, the money coming in isn't changing. So what we have to do is we have to find a way to solve the application problems in such a way that we can peel away some of the application resources and stand up a data team and start working on our data problems. It wasn't something we could tackle right away. And so what we came up with was the SIFSAM platform. And the SIFSAM platform, there was what we did was first, like I said, we focused on the application side. We consolidated a lot of the applications together. We came up with specific technologies that we found for workflows or for low-code tools that would make development faster. And more importantly, we lowered the amount of technologies that we used so that our 3 developers didn't have to know 30 languages between them to be able to work on just maintaining the portfolio. And so as we did a lot of these things, it did allow us to start peeling away the layers and taking some load off of our resources so that we can start focusing on the data. So at that point, we pushed all of our a copy of all of our transactional databases into a data lake, and we started the data program. Lauren hit the ground running pretty fast, and the second she hit the ground, she started going straight to business and forming business fusion teams so that she could study the data that they had, look at what other data they could use, and specifically tailor the data towards SIFSAM domains and SIFSAM views that can solve the problems that the program offices had. And then those domains and those views are what we put out of our data lake into a data warehouse. And the data warehouse then points to all of our analytic tools and all of our visualization tools. And that's, the visualizations from that get embedded back into the applications. And that's what the SIFSAM platform is. So the way I like to describe it, it's a little bit like a octopus, right? So all the applications come down, the data's in the center, and from there, the data goes back out to all the analytic tools. And one of the beauties about having your setup like that is that it's built for change. So if we have an analytic tool that we need to replace or we have a technology we need to sunset, we don't have to worry about the connection to all 30 applications or 40 applications. What we have to do is just have that one point of contact. And when you replace that one point of contact, then with some roles and permission tweaking, all of the other applications now have access to this new analytic tool, and it's a new visualization that they can incorporate. So it really allowed the platform to be built for change. The other thing that was very important with the SIFSAM platform is that it allowed us to see who's using what data, and it really allowed us to control and protect our data better. One of the things a lot of the people don't know about the FDA, or at least SIFSAM in the FDA, is that a lot of our data is given to us by industry voluntarily, right? But not everything is mandatorily given to us. Granted, there's a lot that we get mandatorily, but a lot of our data that we use day to day is given to us voluntarily. And so because of that, it's very incumbent on us to be able to safeguard that data and protect the commercial confidential information that the industry has in order to be able to keep that relationship going. So I've blabbed enough. I think Lauren is rested. So I'm going to give the floor back to Lauren and have her talk a little bit about how she used the Fusion teams to meet our strategic drivers.
So thanks very much for that, Pedram. I think the main points I'd like to summarize and reinforce here are that we did start on our journey a little bit backwards. We started with applications and technology. We started by thinking through how we could create more efficiencies in terms of IT costs and operations, but we quickly realized that we weren't solving some of the fundamental business challenges that our business stakeholders had in terms of their data. And so that's gotten us to where we are with our data program today, and where we are is still very nascent. We're very much still building our foundational data program. And when I talk about our data program within our center, one of the things we talk about is Maslow's hierarchy of needs. So for those of you that have ever attended a Psychology 101 class in college, you are probably familiar with this, but it's this theory around human self-actualization. You cannot self-actualize or realize your potential until you have met your basic physiological needs, and then your basic psychological needs, and then you are able to achieve your potential. The same is very much true for us in the foods program with our data journey. At the base of our pyramid for humans, we're talking about the need for food, water, safety, rest, basic security. The same is very much true for us on the data side for foods. We're very focused on creating a clear inventory of our data assets, a well-organized inventory of our data assets that has clear data definitions associated with it, clear lines of not just ownership, but stewardship, and also subject matter expertise that people can refer back to when they have questions about the data. And then obviously strengthening our data governance processes to make sure that we're appropriately applying policies to various data assets. So make the data healthy, make the data safe and secure. The next level up from that in Maslow's hierarchy is dealing with psychological needs, right? So this is, making sure that people feel loved, creating relationships with other humans, building a sense of self-esteem. For us on the data side, it's also about relationships. It's also about understanding how these disparate data sets that we've been talking about throughout this presentation are related to one another, creating those connections, making sure we understand how data needs to be presented to business. So, and we're also working on harmonization, standardization, just making the data feel good about itself. And then last but not least, the self-actualization portion of Maslow's hierarchy is, for us on the data side, really about how can we help data achieve its full potential. With these other building blocks in place, we'll be able to more meaningfully use technologies like AI and ML to support the work of the foods program moving forward, allowing our data analysts and data scientists to more meaningfully mine data than they can right now, and longer term, create an environment where we have data mesh and fabric in place to support our more strategic business drivers. And so with that, I'm going to kind of close out by reinforcing this idea that for us, FSMA was one of the initial drivers, one of the initial business drivers that forced us to think more strategically about our data. How can we use data to prevent and predict foodborne outbreaks? And then going back to Babani's point for the Division of Information Technology Management, we've been very focused on making sure that we're not creating IT or data products that the dogs won't eat, which is not a perfect metaphor, but hopefully you understand our point. And with that, I'd like to hand it over to Robin to talk about strategic business drivers.
Okay.
Your homework.
Great job, team. So, in closing, we wanted to highlight, we wanted to end this with, we started with the business drivers and we're ending with the business drivers as our our start point as well as our end point in our entire data, technology, and modernization journey. As always, preventing foodborne illness and outbreak underpins everything that the Human Foods Program focuses on. That's our preliminary aim for both our scientific as well as our regulatory sides. And so ensuring that there's data availability and cleanliness and accessibility in this area is paramount. But also with emerging needs such as safeguarding infant health and ensuring that there is access to foods in the infant formula program, that's been huge, and that's a large data set that we're really just now beginning to excavate and uncover. And so that's going to continue to iterate and evolve as we move along. Reducing harmful exposure to chemicals in foods, our toxicology work continues to grow. That's an untapped source in the foods program, but we have emerging need in that, and that's ever evolving. Reducing chronic-related diseases, diet-related diseases is also a huge emphasis for our leadership nutrition and the foods program nutrition facts form. These are some of the highlight or strategic business drivers that you'll see. And there's also a new report that's just recently been released in terms of ways that the foods program, the human foods program across FDA, can improve and achieve some of these specific goals. And lastly, I will turn it back over to Babani. He's going to talk a little bit more about the scientific resiliency and innovation and how that is supporting our strategic objectives as a foods program. Babani?
Yeah. Thank you, Robin. So when something I have to mention, when I came in, I came from ORS side, and I was managing massive amount of data there. When I came in, folks were saying, why can't we get the data directly? What is it? They had coined a word called, we are data deprived. Mm-hmm. And so what Lauren was saying is, so the very first thing is it's the FDA data. Let's make it available to them. And so coming back to the supporting scientific resilience and innovation, I mentioned about this whole genome sequencing, the system that supports a genome tracker. And I did mention about they may not even know that this database that we have is like I refer to as MDM for pathogens that cause foodborne illnesses. So initially that was on-premise in our Wiley data center. And what we would do, what our scientists, what we would support them is pulling data from when they needed to do some analysis with a new sequencing data. They have to go out pulling data from NCBI. They have to pull in some other data sets to run various models and run through Genome Tracker on-premise. That worked really well, but when there was high demand, this would really, really slow down things, and it had to go through our trusted internet connection, which is famously known as TIC. That is to slow down a lot of things. And that's when we realized we're getting most of data from outside, which almost in cloud. There's no point having us in there. That's where we thought about a flexible architecture. That was the first time we started thinking, okay, let's go to cloud. We discussed with with a large cloud provider, and that's when we built a Nest environment in the cloud, which is ETO'd for a FSMA load, and most of our scientific operations, whether it's high-performance computing or even the genome tracker, various models, all that runs there. We receive huge amount of data from our various sequencers, various wireless sensors, and data from outside. And by having it there, we were able to very quickly, using high-speed network, pull in the data and scale the platform so that our analysis can be done very quickly. So this is an amazing experience. And that being said, I think we're very close to what we're presenting, and our data program lead, Lauren, I'm going to, turn it over to her just to, say a few words before we finish it.
Yep.
Lauren?
Thanks. I don't have much else to add there, but I think for the purposes of closing this out, the main point we wanted to drive home here is that for the future, when we're talking about how we want to use data for the foods program, these are the ways that we want to use data. We want to be able to help safeguard infant health. We want to use data to decrease diet-related chronic diseases. In order for that to be successful, we need to partner really closely with our business stakeholders to make sure we understand what data they need to do this type of work. Where they don't have that data, how can we get it? How does the data need to be presented to them? So these are the types of issues that we're looking forward to working with the foods program leadership on moving forward, and we thank you very much for your time, and I think we're ready for Q&A.
All right. That's good. Tizke?
Yes. As the team is taking their seats, we'll have I believe we have several questions available, and I think we've closed the questions from online. Yes, that is the case. All right, looks as though we're ready to go. Pedram, our first question is for you. You've discussed the changes that you're making across the different architectures at CIFSAN. Could you share more about what your current and target analytics environment looks like?
Yeah, actually, I think Swati mentioned a lot about Fiddle earlier today, and so one of the things about the tentacles is that it's not just reaching into analytic tools that we're building inside, but also to tools that are going to be available at the enterprise. So we're really hoping with the direction that it's going that we're going to be able to find a lot of enterprise tools. And so what Lauren and I have done is we've focused a lot of our energy more internally on becoming the knowledge brokers and figuring out CIFSAN knowledge base and what's needed so that we can act as liaisons to the enterprise and try to rely more on CTAB and other groups to try to build and use agency standards and try to do cost sharing across the center. Our leadership still likes cost cutting.
So something to add to what Pedram just mentioned and what we just saw on Robert's presentation is no matter how many Lamborghini or Ferraris we bring in, it's not going to go farther unless until we have skilled drivers. So I hear this, Ram, always talking about training and skills. I think that is something we also have to invest in, training our staffs and providing not just tools, providing them information and training so they can run this Lamborghini better.
That's an excellent point. Thank you. Lauren, you mentioned that you're capturing data from many different data sources. How are you managing the data ingest and transformation processes?
So in terms of data ingest and transformation, I don't think there's anything necessarily innovative about what we're doing. We're using an AWS Redshift environment. Our ingest processes are based on Glue and DMS. But I think this question really alludes to what we're doing in terms of data cataloging. So for us, the priority has been, when we talk about ingest, it's the data onboarding process. So as we bring in new data to our CIFSAN data warehouse or our data lakes, how are we cataloging those assets and then using our catalog to understand the lineage of those assets? So as we are using data within our analytics tools and analytics products, how can we look backwards to understand where the data came from, who's been using it, what are some of the performance metrics associated with the data? And I would say that's really how we're thinking about data ingest right now.
Thank you. Thank you. Pedram, another question for you. It sounds like a lot of the data you're dealing with is coming from transactional and operational systems. To what extent are you working with unstructured data?
So unstructured data right now, we have a small team in the group that is going around to all the program offices. They've already visited most of the offices, and they've gathered requirements. I think first they have to tell them what unstructured data is, because I don't think a lot of people know it as that. But either way, they did an education program for all the program offices. Then they've cataloged all the unstructured data sets that they have, and then they asked them the question of, what questions would you like answered from these data sets that you can't answer right now? And based on that, we have gathered a lot of use cases for the center, and a lot of them are common use cases, and we believe that a lot of the other centers have common use cases that are parallel. So what we're doing with that now is we're going to be presenting to Ram's group and the Enterprise Architect group, and we're hoping to do an enterprise analysis of alternatives to figure out what tools can be shared across the centers in order to solve some of our unstructured data needs. So more to come.
Now, building on that, do you have any plans to allow the public to use your data?
So I think there are some programs where the public already uses our data, and I do know definitely that we have some other programs that we're trying to get funding through legislation that will allow just that. I'm thinking supplements is one that comes to mind, by the way.
And I know a lot of our outbreak data, it's already been made widely available to the public, but there's still much improvement that could be done in terms of capture of that data. That's something that we're actually working on right now, especially with the new traceability rule that has kind of recently gone out. That's going to represent a new data set. So that's something that's also going to be made widely available. Frank Giannis talked about that, right? The trace forward, trace back, and the program that the OFPR group is already working on. So we're closely working and closely aligned to them on that, and ensuring that data that should be made public can be made publicly available. And then also, lastly, I will say that we also have a huge consortium right now where we're sharing data with academia, industry, right, and with other public and federal entities. That data is right now being housed in the cloud and is accessible for upload and download. And so we've been successful in being able to share data out of the agency, but we expect that to expand over time, and we intend to absolutely work with enterprise solutions that are being designed and thought about right now to help kind of grow the foods program data repository.
Great. Thank you for that additional detail. Bobany, we've been hearing a lot about the new traceability rule for foods program. How is what you are doing for CIFSAN related to those initiatives?
I'll start off, and then I'll turn it over to you. But as I mentioned, it's going to represent a new data source for us, right? It wasn't something that was mandated in the past, but now with the new traceability rule, it's a data source that we'll capture. We're actually working on a solution right now that helps to integrate our existing kind of foods program data ecosystem with data that we receive from other sources to help capture and correlate all that data together and be able to disseminate and share it out and make certain decisions. So, it does provide a growth area for the foods program. I'll say, as well as it'll help us to get greater insight to support the ecosystem of, our post adverse event outbreak, but also for prevention and prediction as well. I think that's a big area that we want to move into. Brian?
Yeah, thank you, Robin. I think you covered it really well. This new rule that just got published, it's about a couple of weeks back. What this gives us is that we would be able to track food products starting from the farm to the table. So the farmers, the facilities that manufacture those things, or even the grocery chains, they're required to track these things. They're required to track all their supply chain to provide us the data when we need it. So I think this is going to be a huge, especially when there is an outbreak, rather than going through all this a lot of different changes and trying to figure out where this product or ingredient has traversed through. We would be able to receive this data quickly and analyze this data, so to trace back where this thing came from and be able to stop this from being, getting involved in various other things. So that is something new. And in this, one of the major things you may be wondering, is it not happening right now? It is. But the challenge is, there is no standard that, provides these various manufacturers to how they should, track this data or store this data. Through this rule, we have clear guidance. There are two sets of it. One is about various transactions, and then the other thing is about their supply chain, where it came from. So those things will be clearly captured in a certain standardized way. When they are given to us, we would be able to make it visualization so easily our compliance officer, our analyst, they can easily see through various, analytics, where it came from and easily be able to take action on that.
Thank you. We have time for one more question. I believe this is for Robin. Are there any upcoming service or technology contracts that you can share information about at this time?
So actually, we do have some opportunities that should be coming out, but we're also partnering with the agency as well, and we leverage enterprise-wide. We like to leverage enterprise-wide acquisitions, right? It helps to streamline, it helps to save time. So I highly encourage interested vendors to look at Fed's BizOps and to stay attuned to media sources for any outcoming IT acquisitions, data technology acquisitions, to help partner with the Foods Program and FDA data and tech program as a whole. So we highly encourage it, and stay tuned.
Thank you. And I'd like to thank the panel as a whole. This was a great presentation. We're now at our final break of the day, and we will reconvene promptly at 2:45. Thank you.
Thank you. And I really want to thank the backend team, Amy and her team, and the entire ODT staff for what an amazing job you all have done. I know it's not easy, and lots of kudos to you all. It's been great, very eye-opening presentations. Thank you.
Thank you.
Thank you. I hope everyone had a good break. Welcome back. I hope you had a good break. Our next presentation is titled Research to Review, Program to Empower Digital Transformation from the National Center for Toxicology Research. Please join me in welcoming the Branch Chief for Research to Review and Return, R2R, at the Division of Bioinformatics and Biostatistics of NCTR. We welcome Joshua Shu. Joshua?
Thank you for the introduction, and glad to be here. And thank you for ODT for organizing the symposium. Okay, so it's the outline of my presentation. First, I will talk about who we are and where we are, in case that you're not familiar with NCTR, and then a brief overview about the R2R program, and then I will share 3 R2R projects and to show that how R2R program works. FDA label is in collaboration with CEDA, and then Assist for Tobacco is in collaboration for CTP. And then we have the Safety AI. It's actually a CEDA-initiated AI project. Okay, first, NCTR, where it's located. We are not in the D.C. area. We're 35 miles south of Little Rock, Arkansas, and about 1,000 miles away from Washington, D.C. And now with all the teleworking technology, Zoom and team meetings, and we feel that our distance to D.C. is 0 now. We have 500 acres of properties, and they're all owned and operated by FDA. This is quite unique within the FDA. We are nested in miles of pine wood right beside the beautiful Arkansas River. So NCTR was established in January 1971 by President Nixon as a long regulatory national resource. We aim to conduct integrated toxicology research and foster interagency academic and industrial collaboration in support of risk assessment to promote public health. We have over 1 million square feet of space in 30 buildings and over 100 experimental laboratories. So within the 5 offices at NCTR, we had 6 research divisions and about 500 employees. So the research that at NCTR was directed toward to provide reliable scientific data for FDA's decision making and develop innovative tools to support FDA's public health mission. So over the years, of course, the research area has changed and updated along with FDA's mission and the current challenge and needs. So below are the focus areas right now: artificial intelligence and machine learning, biomarker identification, bioimaging, nanotechnology, molecular toxicity, and One Health. You may not be familiar with that term, and CPM colleagues will explain what it's about. Prenatal and maternal research, and last but not least, precision medicine. So in this presentation, I will talk briefly about the AI for toxicology program we just initiated at NCTR by our division director, Dr. Wei Tong. And we have 4 initiatives under this program. The first one is called Animal GAN. We utilized the AI approaches as alternative models to generate data from animal study. So the model learns from existing animal study data, and by taking the dose and chemical structure and duration information, we generate animal study data that can be utilized to screening the new and untested chemical and to prioritize and to help better prepare the animal study. And then safety AI, I'll talk a little bit more later as one of the R2R program example, and we utilize the AI models for toxicity endpoints that are critical to the drug safety assessment. And then bird talks, we use AI-powered natural language processing to support toxicity assessment of FDA documents. And we always say that FDA has a lot of data, but actually there are shows in the form of like documents. So documents processing and extracting information and knowledge is very critical to FDA's mission. And then last one is pathology AI. Early that CDRH colleague and talk about digital pathology, how to develop the reference standard, and this is more for clinical pathology. Here that we are, the NCTR do a lot of animal studies, so we are more focused on to develop a AI-enabled framework for preclinical digital pathology. So I will not talk more about number 4 or number 1 in this presentation. So for more information, please go visit our website, listed below. Okay, so why we established this R2R program, what it's all about. And you know that at NCTR, we do a lot of research, and the research is to provide the data and then build the tools to support their regulatory application at the product center. So we want to do the last mile, is that to translate our research in for regulatory application. So directly build tools and put the reviews to hand so they can use. So we leverage the diverse skill set at NCTR. We have database design, knowledge-based development, programming, system integration, and AI and machine learning, data analytics, of course, and the biomedical research expertise. So we start the program in 2014, and over the years, and we have two arms. One is that we translate our research results and to help build applications to support regulatory application, and then on the other arm that we want to get in the data from our regulatory colleagues and to liberate the data to impose research that would complete a virtuous cycle. So over the years that we have worked on a suite of projects. Currently, that we have 5 projects have entered the phase of production and enhancement. And then currently we have 5 in development. We are working with CEDA and CTP and ORA. So that is a framework for R2R. We utilize a agile and recursive approach, allow us to have periodic interaction and with the reviewers, and so that we know what the needs, what the feedback, and to advance the development. So we usually start with the exploration, and either it's face-to-face meeting or it's a teleconference, so that we could know what. So for them to know what research we have done, what kind of tools, that prototyping that we have, and then for us to know that what the needs are. So in that phase, we clarify requirements and communicate possibilities. And then we move to the next phase, assessment. And this is rapid assessment, and we produce more refined prototypes, and then discuss with them, and then explore alternative approaches. And at this stage, that we may decide either it's a go, or say that we demonstrate feasibility really is important to go forward. And then we have the go single, move to the next phase of execution. So that it will be the formal development with timeline and deliverables and schedule and all this. And then successful development of this stage would move to the completion, more the production and enhancement. But sometimes that some projects would look back and for further evaluation, maybe shelved for future consideration. So in the last stage, we're aiming to do the summary and to draw the lessons and to be able to share the lesson learned and technology development for other projects as well. So indeed, this is a very agile and collaborative framework. So we'll now move to some examples and to show that how the R2R framework works. The first one is FDA label, and currently is in the production enhancement stage. And as you can see, that is already deployed in Amazon Cloud, and you can check it out. And current maintenance and enhancement is under the CEDA NCTR MOU. So this indeed is it's a collaboration with many offices in CEDA, Office of Computational Science, spearheading the collaboration, help us to communicate with other partners in CEDA, particularly in Office of New Drug, Office of Generic Drug, and Office of Surveillance and Epidemiology. So FDA label, in short, is a web-based database for managing, querying, organizing drug labeling and other product and labeling documents. And it has a user-friendly interface. They enable the user to search the whole document and also any section of choose or with combination with other other type of criteria, such as the marketing category and such as when to get marketed, and then such as pharmacological class, so on and so forth. And it is integrated with other FDA resources, such as Drug at FDA, Orange Book, and Purple Book. And we update it weekly, and currently it has over 140,000 labeling documents. It's actively used by CIDA reviewers, and we also have a public version that can be used by researchers from the public. So why we developed this FDA label? This is could be a typical story of the R2R program, and we initially encountering the drug labeling documents when we are doing the drug-induced liver injury research. So we use the drug labeling as an important source of documents to review and study the adverse event of regulated drug. So as we doing that, we build a pilot, and then we show the pilot with some of the collaborators in CIDA, and they immediately point out that actually this helped to address some of the challenges they see with the review of labeling documents, such as rapid growth of drug labeling data, and there is also a major format change in 2006. And then how do you compare those documents with different format, and how do you cross-search? And then there are also there are complex relationships between labeling and drug documents. There are generic drug, and they have to mimic the reference labeling drug, and then there are relabeled drug, and then there are repackaging the drug, so on and so forth, many challenges. And so they need a flexible, powerful, and faster tool to manage and the data, and then enable complex search. So we developed the tool, and then we also particularly listen to their needs, that we enable the search terms that can be stored and shared, and then can be periodically updated. And so currently, FDA label is in maintenance and enhancement stage. So we have this enhancement cycle, and we look at some of unmet needs, and we look at new requests from the feedback, and we then do the feasibility study, and we talk with the user, and we choose some of them to design, and then we develop, and then put it back to the user group. There is a group of super users for them to evaluate and testing, and then when it's passed the testing, we release that into the new version. So this full loop is repeated in every cycle, and you can see this is more it's more like an incremental change. It's not a paradigm shift, and then you may be thinking that what's next, and we planned something that to significantly change how the search criteria work by utilizing the natural language processing. This is actually part of the research results we borrowed from BIRD Talks, the initiative number 3 under AI for Talks. So use the BIRD model developed by Google. BIRD means bidirectional embedding representation transformer. So this AI-enabled model is built on generic text, like Wikipedia. So we fine-tune it with labeling data. So with this custom domain-specific BIRD model, and we were able to search the labeling document with more accuracy, and then also taken in count of maybe even the misspelling and the syntax. And we have already demonstrated that it will be able to improve the adverse events recognition from the labeling document. This is important because is that when they were doing adverse event report and keep track of them, they want to know what is already in the labeling document, what is new. So next project, and we shift gear to work with talking about our collaboration with CTP, and this is advanced semantic search and indexing of text for the tobacco application. So CTP's Division of Regulatory Science and Information, DERSI, and our division, DBB, will collaborate with the business stakeholders at CTP's Office of Science. We are developing this system to use semantic indexing to search tobacco authorization application. So CTP received close to 1 million submissions every year. And then in some of the submissions, they have hundreds, even thousands products. So to search the information about those products and to conduct a timely review is not an easy task. So we are working with them to develop a natural language processing enabled system and also leverage the internal data from different sources. So we work closely with stakeholders and at CTP, and we input and getting the feedback in terms of design, that how system work, the architecture and features, and how the user interface. And we also integrating the ad hoc automation requests that are received by DERSI, such as product extraction and environmental assessment check, such as component and then the product ingredient extraction for chemicals. So in order to develop something to meet the reviewers' needs, that we spend a lot of time to talk to the reviewers to understand the pain points during the review. A lot of them is related to query information and navigate in this submission. So, for example, some of the submissions are poorly organized, and many of them do not have a table of content, or they do not have a clear table of content. And then there are many large files that contain files could be close to 1,000 pages, a lot of variety information and difficult to navigate. And then sometimes the file names is difficult to interpret, and they have abbreviations, and sometimes they don't even match the content. So the simple keyword search could miss relevant content, and then could also lead a lot of irrelevant information. So really present a challenge in the review. So we built this. This is a 3-mile overview of the system architecture. We have the system in, and then we build a natural language processing. This processing is based on 2 arms. One is that we build the BERT model with the custom annotated to information such as named entity recognition, and then we build this model. And then on the other side, they also have the knowledge base from the reviewers. So this knowledge base manufactured as a network of keywords and combination of keywords. So periodically, we update the model and the knowledge base, and to ingest the data, and then to produce the information for quicker review, such as clear table of content, and then also that the automation and check, and then also bookmark and mapping the section of the document to the specific review needs. And then, of course, also extracting all the key information like product name and table and ingredients. So this is our development roadmap, but it's actually not a step-by-step. Is on the top layer is more the part that we are implementing one after another, but the bottom is more the foundation to support the system. So we have that first is file upload. They'll be able to ingest all the different files like PDF and like image and like docs and like Excel tables, and then we handle all this. You created a project and then have managing the files. When they upload the file, we have asynchronous task management. So we were able to digest the different format and detect the table and extract the table, and by utilizing AI-based layout analysis. So at the end, we generate a table of content. So we then map the information in the file to the review template. So the review template have different sections, and in next slide I will show that the different sections and how to map, and then that would generate automatically bookmarks, and of course that will also give the user capability to manually add in the bookmarks. That would serve as the user data to import the next round of AI training. So right now, we are integrating advanced NLP for bookmarking. And once we implement the user profile and authentication, that we are going to move the system from the development server to testing server. So we are in the third year of the program. So here, that is an example of chemistry review. In the section 2.5.2 is about ingredients. And then a table from this PDF file was extracted and about the ingredients, and then was mapped. So when the user clicked that link, it would directly point to that table. And finally is the Safety AI project. This is funded by CEDA Intramural grant, that we are developing an AI framework to assist the CEDA IND review. What is IND? So investigating new drug application, establish the safety profile in the first human dose for a drug candidate to enter the phase 1 clinical trial. So the important information is that this is the point that they were allowed to start the human testing. So it's very important to making sure the drug candidate is safe. So the applicant provide a safety profile, and then on our side, that we want to do all we can to know that whether this is safe for human testing. It has a very tight clock, 30 days review. So we want to see that whether AI can be used to support IND review. It's not that AI would magically and do that. It's that how that AI model can be built from the existing data, from all the data that FDA has accumulated to understand this new drug candidate. Actually, internally, FDA has been promoting alternative methods, including artificial intelligence, to support drug discovery and development. And outside FDA, internationally, there is a push as well, and moving toward that direction. The most pressing reason is that any model has been shown that not so effective. That's why that we are looking for more effective method to assess drug safety. Of course, it also replace, reduce, and refine animal use. So in that project, we are developing a set of AI models to tackle different safety endpoints, such as like liver toxicity, carcinogenicity, and mutagenicity, kidney toxicity, and cardiotoxicity. We have 2 models already developed and published, and they are under evaluation by the regulators for the regulatory application, and then other models are being developed. And we developed a novel AI approach using the model level representation of the drug features and to predict the safety endpoints. So with the DILI as an example, and then I'm going to show you that why they were looking for the alternative method. Close to 50% of drugs that failed in clinical trial or are withdrawn from the market after they have been approved due to the liver toxicity, they were not predicted by the existing preclinical models. That's why that we need alternative method. And then our model is based on chemical structure information only. And we utilize the drug approved before 1997, and whether they have the DILI toxicity. And then we're predicting the drug approved after 1997. We achieved 70% of accuracy. So this means that that can be helped to support the IND review, getting additional information for the review to consider, and maybe they would ask the sponsors and to pay more attention for the need for toxicity testing. So I hope that I give you a clear picture of the NCTR R2R program, and it provides an agile and collaborative platform for translating NCTR research to regulatory application to support the review at the product center. And we often employ AI machine learning technologies and then deploy the system to secure government cloud environment. We utilize the extensive skill sets across regulatory research and system development at NCTR to support regulatory application and empower digital transformation. And of course, Roman is not built in one day by one people, and we do have a lot of collaboration. We appreciate our collaborators at different centers of FDA. Thank you for your attention.
So Joshua, we do have several questions if you have a minute. Is the BERT training library available in public domain like Hugging Face, sorry.
Oh, Hugging Face. The library that we have trained, of course, that we have not put in back into the Hugging Face, and we evaluate the BERT models in the Hugging Face and to see which one that better for our use, and then we refine and tuned with our domain-specific text data.
Thank you. Another question, is the FDA predictive toxicology roadmap publicly available?
Repeat the question, please.
Is the FDA predictive toxicology roadmap publicly available? We can ask for more information from
I think this is many centers have projects in that roadmap, and I think that Probably if we ever ask a question, probably can find more information at the FDA website.
That's a great answer. Thank you. And to always go to the FDA.gov website for more information. I do have another question for you. What is the average duration of R2R projects?
Depends at what stage that could exist. So we normally want to complete the first two phases maybe in several months, 3 to 6 months. And then if it's getting into the phase of execution, then that project could be maybe 2 to 3 years.
And where will the new R2R projects be deployed? In the cloud, on-prem?
At the beginning, we tend to deploy more to on-premise servers, and now more and more we are towards the cloud. So because the cloud actually gives us more flexibility, and then also particularly that with the newer projects that we are involved in the AI, machine learning, and cloud with the GPU support really provide more flexibility.
And how can someone begin to explore a new R2R project with your group?
Oh, that's a very good question. So please talk to us, and then whether you are a vendor and you have technology that you feel that maybe can be applied to FDA. So we would like to better to know your technology, and then to see that to see what the review needs or the research needs that we have, and we can work together with you and to trying to customize or work with you, customize your tools, and then for regulatory application. And then if you are from FDA, and so we definitely want to listen to you and to know your needs, and then to also to show that what kind of like research tools, research results that we already have, and then maybe that we can explore a good match.
So pivoting a little bit, how many years of drug data are there? Is there a reason 1997 was chosen as the cutoff year for the training data?
That's an interesting question. And I think the reason that we choose 1997, so the drug has been marketed quite a long time, and then any toxicity would be well studied and known, so that the data, particularly liver injury data, would be solid and reliable and be used to predict. Of course, we also want to have a sufficient body of drugs that we can use to do the training of the models.
So Joshua, I have a couple of questions for you on AI. How do you work with reviewers to make sure that AI models serve their regulatory purpose?
There are two parts we really emphasize. One is the context of use. And so maybe you can say the intended context of use. So how this model is going to be used at which stage, whether it's just to extract the information for them to consider, whether it's to produce prediction results for them to evaluate. And so we need to evaluate the model at this context of use. That's one. And then the second is that we really emphasize interpretability, the explainability. We want to explain that how the model works, and then what need to the model's results, and explain that part, making sure that our results can be understood and make sense to the regulatory reviews.
And staying on with AI, do you plan on adding AI to the 5 R2R projects that are already in production?
There are components of those projects that are already in production, and such as data collection and data processing, and some of them they were done manually. So would be interesting to add AI and machine learning component to automate those processes, and then also to increase the consistency of the data and also the quality of the data. So yes, we are planning to add AI and machine learning capabilities to those projects. But of course, we need to get the system owners, the business owners, to get their buy-in.
Excellent point. Now, you've presented several examples of research to review. What about the return from review to research?
That part, let me take this opportunity to clarify a little bit. And what does the return means? The return really means that we want to tap into the submission data, and then to this data that maybe that can be blinded in a certain way that then can be used as for our research, and then that can be to advance our research and to develop better models and better research tools, and to go back and to fit into the regulatory review. So far that even that so you may think that the CTP project is a return, but actually it's not, because this is still that the data stay in the system and cannot getting out, cannot be borrowed by other projects, and so we are actively working with different parties and trying to explore that what are the venues, what are the loops that we need to jump, be able to liberate some of the vast, valuable data that FDA has.
And Joshua, one more question for you. What are the most common challenges that you experience?
That's a great question. And some of the challenges that we experience, as we move, and even that from the on-premise and then move into cloud, we still experience quite a bit that the delay in getting the environment in setting up. Sometimes it's just the cloud environment that we got, and still requires a lot of steps, and then even that they were not able to quickly set up, even that when we set up, that we will not be able to quickly move in our system and to do the deployment, and also in the testing. So that is one that we would like to getting better, more efficient setting up of the development and deployment environment. Another one is that we encounter is that usually that we're thinking that there are many. The industry has been doing something really advanced, really great, such as I would not mention the name. That maybe they have the process, and they will be able to like mention that this morning about processing the video and doing the transcripts, and then also extracting the text from the image and all this. Those we so far that we don't have luck in getting used to those advanced AI services. So that is something that we would like to tap into. And then the third one that we commonly experience is as you see that a lot of our work is focused on the using the AI and machine learning, and the AI cannot come from anywhere. It requires you to feed quality training data. So many times that we have difficulty to get the good training data.
Thank you. We appreciate all the time you've given.
Thank you.
Our final presentation today is with the Center for Veterinary Medicine. Let's welcome Doug Margulies for his presentation, CVM Modernization, One Health.
Thank you so much. It's very exciting to be here today. It's standing room only here at White Oak, which is really exciting to be back, and I'm really grateful for this chance to chat with you all. And of course, I'd like to thank our hosts as well. It's really a wonderful, wonderful opportunity. Of course, my name is Dr. Doug Margulies, and I am a licensed veterinarian, and I'm also a technologist. So it's really exciting to be a part of the Center for Veterinary Medicine's mission, which is protecting human and animal health. It's what we do, but understanding that mission takes a little bit of thought, and working very closely with business, we really wanted to dissect that life cycle as the absolute foundation for what we're trying to do in modernization, because first and foremost, we have to understand and serve business. So what we do is we ensure that animal drugs are safe and effective, they're properly made and adequately labeled and packaged. We ensure that when food-producing animals, such as cattle and chickens, are treated with drugs, animal drugs, that the food made from these animals, such as meat, milk, and eggs, are safe for people to eat. And of course, we monitor the safety of all types of animal food for all types of animals. And we also monitor for side effects and product quality problems that are reported for animal food, drugs, and devices. And of course, we work to make more animal drugs legally available for minor species, such as ferrets or fish, and for minor uses in major species, such as horses and dogs. And that's just a few of the many things that we do. So that's got to translate into a life cycle. Well, so we talked about it. It's drugs, it's foods, it's devices. And what we do is evaluate, surveil, and comply. So let's kind of take a deeper look at what brought us to modernization. And of course, for us, for the Center for Veterinary Medicine, it's a voyage of discovery. How do we actually understand what's going on and better serve all of our stakeholders? We know and understand that offices, business units, analysts must hunt to find information from multiple sources. Once gathered, they've got to correlate all that data and be able to perform proper analysis and decision making. You've heard everybody today talk about different silos. You've heard a lot of discussion about disparate systems, disparate stakeholders. We're no different, right? Whether we're talking about drugs, foods, and devices, each being in a separate pillar, or if we're talking about all of the different things that are happening and not being able to see the correlation, or simply just that our systems don't talk to each other. And last but not least, even getting our offices to work together and see one set of data, see one workflow, see one life cycle is paramount to our success. So really, our whole vision for modernization is a future state where we're able to respond to human and animal health challenges. And we really want to go from reactive to proactive. So there on the left side of that screen, you see a whole bunch of disparate lines going everywhere. We've seen all of these different technical diagrams that I can't even begin to understand because there's just too many lines, too many boxes, too many arrows. And what we realized is we need a single management system, one record of truth they talk about, one workflow system, one database system, one ecosystem, right? And we've heard about FIDDLE, we've heard about the cloud, we've heard about all these things. We all need the ability to respond to human and animal health challenges. And really, that brings us to what our vision is. Let's go from reactive to proactive. Let's protect, let's predict, let's prevent human, animal, and environmental health challenges. That's the One Health Challenge. And by really taking a data-first approach, we'll be able to adapt and really function and thrive in this ever-changing environment that we call the FDA. So our goals are really simple. And the most important thing when we think about modernization for the center is it's got to be data-driven. How do we bring the data to the forefront? And so we want to focus on the science and not finding or accessing data. We want better access. Make it easy, a single place to go. Get all the information you need with one simple try. And then obviously we want to be able to use that data every day. We're responsible for populating templates and forms. We want to do that automatically. So we want to bring that data right in so that all of our staff are able to see it, able to use it. Forms are automatically populated from submission data or from any of the review work that they're doing, from our research, instead of always having to cut and paste. The next is the ability to change at the speed of business. We know and understand that this is a changing environment. We've got to be able to respond. We're faced with all sorts of public health challenges. How we respond to those challenges is very important. We need flexibility, scalability, extensibility to meet evolving business needs. We also need better self-service tools. We need business to lead this charge with us as a partnership, hand in hand. And so as we begin to imagine these new tools and these new technologies, as we begin to imagine modernization, it starts also with this concept of self-service. And then, of course, this one-stop shop idea is something that's not new to anybody, but it's not just a portal. It's more than just a single gateway, and of course, it's more than a cloud-based solution. For us at the center, one of the founding principles for our modernization is this idea of X as a service. We want to engage ODT and rely on them as the experts to provide us with the service that we need. It enables us to focus on the science as they provide us with the solutioning. They have made unprecedented strides to help understand our business. Swati's in the audience, Ram, Vid, the others, all my friends, because we meet regularly and they're partnering with us to learn and understand our business challenges, our business needs. We don't just solution for, oh, here's a single thing to solve a single problem. We look at the big picture, we understand, and we want to make sure that everything's in there. And then last but not least, CVM is really special in that it's a microcosm of FDA. We really like to say we're small but mighty, and it's not just because we do a lot of important work, but it's more because we are an absolute microcosm of FDA. We surveil, we comply, we evaluate foods, drugs, devices. We pretty much do it all. We don't do tobacco, we don't do cosmetics, but we really do the bulk of what you see here at the center, at the agency. And I touched on it briefly, but our goal with modernization is to really build a solid partnership. It starts, and I was so grateful to hear this throughout our conference, it starts with this idea of business first. I can't pretend I know and understand what my constituents do over in foods. I'm a veterinarian. I have a much stronger understanding of animal drugs. But knowing and learning their business and ensuring that I'm able to speak with them and that I understand and that I carry forward their needs is equally important, whether it's drugs, foods, or devices. Similarly, we've got to put our enterprise hat on and understand where the organization is going, because it's not just about one pillar. It's not just about surveil. It's not just about food. It's about understanding from an enterprise perspective how all of these things must come together. And then last but not least, and it's been great again and to be a part of this, then technology can come in. Once we have that understanding, we know and understand the business need, we know and understand where the organization is headed, now we can try to apply technology holistically and really have a big picture view. So I talked about this life cycle initially, and now I want to bring it back, but really introduce this idea as, well, it's as a service, and how do all these pieces come together, and what does it mean from a business perspective? And this diagram to me is really awesome because it says, you know, when we look at drugs, foods, and devices, when we think about evaluate, surveil, and comply, what is the data flow? What is the workflow? What analytics are we going to be doing when we're considering everything that goes into it? But it doesn't stop there. We talked briefly about some of the scientific computing that's going on. How do we look at genomics? How do we look at the omics of medicine or even food? And then also, how do we provide service across that spectrum? When we think about a total architecture for the center, have we considered how we move open source software or shared data sets from the scientific computing environment back over into our workflow or our data. As a reviewer, if I'm examining a huge data set, I need to put my findings through the workflow. All of this needs to be connected, but in a safe way and as part of what we do on our day-to-day work. So it must be integrated. So workflow is integrated with data. Data is integrated, of course, with analytics. That's integrated with our scientific computing front, and all this is linked by our service front. More importantly, there is no single source from the standpoint of all of our data must be in a relational database or a data mesh or a data fabric whereby any event can be seen across drugs, foods, and devices, or the whole of surveillance, or the whole of the life cycle. It's very important when we think about something like an outbreak, are we talking about the impact of the food supply chain, of the drug supply chain, of the device supply chain? Well, for us, it's all three. And we've got to be able to quickly and easily answer that question. So what happens if we're successful? Well, we know and understand that it's going to be a single system linked to all the centers and, of course, the FDA. And we're excited to say we're also on the FIDL environment, and we're inside of the ODT enterprise architecture. We're using that same environment to give us customized dashboards, reporting, and search in a pooled analytics suite. The big change for us is that we're going to be able to hopefully give real-time access to data and analytics on all of our workflow over time. Of course, we want to reduce the amount of cut and paste. We want to change the way that people do their work to make it easier, so we want data to be pre-populated into templates and workflow. And this will allow for optimization, reimagined and improved process for all that we do. And last but not least, we want to view this as a whole life cycle. There's no single data element. There's no single view of something. We want to recognize it within the CVM portfolio and eventually even within the agency portfolio. So this is just a notional timeline, and the point is we're a little bit late to the game. It's so excited because I've been able to talk to CIFTAN, the CEDAR, to all of my sister centers. We're really just starting our experience. We kicked off about 3 years ago. We did the audit. We looked at how we do things. We talked about where we want to go. And for us right now, we're starting with our drug life cycle. We're hoping to accomplish that in a couple of years. Then our next focus is external. And this is something that I really think is exciting for us, which is to change the way we think about and collect and use data. Right now, we're really about digital paper. How do we become a truly data-driven environment is to start at the source. We must focus and spend some time working with our external stakeholders and reestablish and work with them to collect data smarter and easier for both parties. You know, we want to shift away from a paper mentality or a paper-driven electronic mentality and see if we can embrace some of these more modern methodologies. Next is food or food and devices, really. You know, and whether these take 1, 2, 3 years, it's always resource and other dependencies in there. But it really just helps us understand this is a long and ongoing effort of continual optimization and continual modernization. And then last but not least, again, it's really exciting to hear things like laboratory information management systems. We do research. Things like some of our unique collection processes or scientific research methodologies. How can we improve and bring those specialized workflows into the work that we do on a daily basis and have that data inside of our larger construct? So I've intentionally tried to be quick and brief. I talk fast. I did want to take some time to answer some questions. I know there's a lot on people's minds. So with that, I will turn it over and answer any questions.
Thank you, Doug. And we do have a couple of questions. What are the biggest challenges the CVM modernization team is facing?
So I think our number one challenge is kind of what I ended on, which was how we collect and use our data. I know one of the things right now is we don't have easy access to it. It can take sometimes weeks to pull together all the reports, to do all the necessary reviews, to bring in all the offices and get consensus on what it is that we're trying to answer. So we're working closely with the ODT team to ensure we envision the best possible way to collect and capture our data. Another one is to think about the discussion between business and the enterprise on where we want to begin our focus. One of the big conversations we have, and one of the things I see, is we really focus a lot on the scientific data. How do we provide AI ML to unlock this really large, unwieldy attachment and begin to understand what's in there? And one of the questions I have is, well, if all of that information that's trapped inside that attachment, what if some of it came as part of the application process? If that was in our database, could we use machine learning AI better to inform actually what's in there? Maybe if we focus first on what we receive and how we receive it, then we can get better at doing some of the more interesting and exciting work around AI ML that's uncovering what's buried in there. And then I think the last big challenge that we face that I think everybody faces is shifting resources and priorities. It would be great if it was all heads down and all focused, but we have to be able to respond to whatever's going on in the environment, and we also have to be able to respond to emerging priorities and challenges.
So looking at the other side of that coin, tell us about some of the biggest successes of the CVM modernization.
That's a great question. To me, and it's one that I think I'm most excited about, and that's really the partnership with business and the partnership with ODT. It has been an open exchange of ideas, and business has really come to the table. So working closely with drugs, foods, and devices to understand their challenges. We probably have 10 or 15 years of backlog of ideas, and we're finally getting to a point where we can start to really understand and see the big picture and provide reusable frameworks that everyone will hopefully be able to see in the next year or two. Similarly, ODT, ODAR, the FIDDLE team, the DSC have all really been engaged, but more importantly, they've been focused on learning our business and providing more than solutions. They've been providing understanding, ideas, and most importantly, partnership.
I have one last question for you. How does One Health play a role in modernization?
That's a challenging one, and for us, it's really, One Health is about understanding and embracing the relationship between human, animal, and environmental health. And for me, it's about understanding how we've got to create a system that shows that information easily, really exposes things that we're seeing. Part of our responsibility isn't just, oh, what is the impact on the animal? More efficacious drugs for animals. It's also, what is the impact to the human, whether it's in the tissue and what we eat, or just as a result of how it enters the environment. What is the environmental impact of this drug? We've got to be able to provide that information in a better way to allow our staff, to allow reviewers and analysts to really see it and get ahead of it.
Thank you, Doug, for sharing all the great work that CVM is doing.
Thank you all so much. Have a wonderful day.
So we've made it to the end of our second day. For tomorrow, we'll have one final keynote address where we welcome Gartner Research after lunch, who will talk about emerging technology trends. I want to thank everyone online for joining us and making it to the end of a very exciting and content-filled day. I hope you can join us tomorrow for our final day. As a reminder, you may navigate to the Symposium website for event materials and send questions to ODT vendor engagement at fda.hhs.gov. For our final day tomorrow, the link to access the virtual symposium is the same link you used today. Please do not share those as they are unique to you. I hope you have a restful afternoon and evening, and we'll see you again when we reconvene bright and early tomorrow morning at 9 a.m. Eastern Standard Time. Thank you, and have a good afternoon.